AWS Virtual Private Cloud. In this video, I'm gonna explain the components of AWS Virtual Private Cloud and also how you can set up using the AWS console as well as the Terraform code. Make sure to stick to the end of this video where I'll share with you a special bonus. It will be the Terraform code to set up your VPC. So let's get started with the components of the VPC. Is kind of an abstraction, just a logical component, and the core parts of VPC are subnets. So let's just express them like these. VPC has multiple subnets. The subnets is the logical boundary of our network, and in this case we're talking about virtual network. So each subnet has a specified IP addresses range. It's called CIDR block. Whenever any service is running in the subnet, it receives an IP address, and I'm talking about internal IP address within the specified CIDR block. So why do we need subnets anyways? Everything that is deployed in our VPC could be interconnected. So let's say we have multiple services deployed to subnet, to our VPC. So the service 0 and service 1 deployed to subnet 0 and then service 2 to subnet 1. As far as all of these services are located within the same VPC, they can easily interconnect with each other. So there are no any kind of network restrictions to interconnection among these services. But we still have these subnet boundaries. And the subnet is something that related to the physical structure of AWS region. I'm not gonna be covering this in details in this video. However, if you're interested in learning more about physical structure of AWS region and how the network is set up in AWS region, make sure to subscribe to my channel as I will release the next video about this topic. So AWS region has something called availability zones. Usually when you're creating the subnet, you assign it to the availability zone. And this availability zone is a completely physically isolated part of the AWS region. We need it for reliability, because if some hardware in AWS region goes down, it means that only one availability zone goes down. So in our case, only one subnet goes down. So let's say if subnet 1 is down because there is an issue on AWS availability zone, so we can move our service to subnet 2 and it will continue functioning well. It could be done manually or automatically depending on your infrastructure setup. So that's the main motivation of why we have this subnet splitting. Another motivation of why do we need subnets within VPC is network access boundary scope. We're going to be talking about it in a minute after I'll explain you a few other parts of AWS VPC. So another two important networking parts of the AWS VPC are Internet Gateway and Net Gateway. Internet Gateway is something that lets our services to be publicly accessible. So let's say we have service 0, which is our API. We want this API to be publicly accessible. By default, if our service is deployed in VPC in subnet, the network configuration for this subnet is set up to work within the local private network. However, we want our API to be also accessed from the outside world, from the internet. That's why we need to connect it to Internet Gateway. We need to set up the Internet Gateway and connect our subnet to the Internet Gateway, so all the services that are located within the subnet will receive public IP address, so it will make them accessible from the internet. And remember that we've been just talking about subnet's purpose. So, and another subnet purpose is the network boundary. So we can label subnets as the private and public. So what are the differences between private and public subnets? So the private subnets, the services deployed in the private subnets, are only accessible within VPC. So let's say subnet 1 is private. It means that, and subnet 2 is private as well. So it means that all the services that are within subnet 1 and subnet 2 will only have a private IP address. So there is no way, no physical way to get the network connection to these services from the internet, from the outside world. While the services located in the public subnets are accessible through internet gateway, and as soon as they getting deployed to the subnets, they receive the public IP address that you can literally type in your web browser and will establish connection to the server, depending on which kind of connection you have. So this network boundary helps us to create more security around our services. So let's say here we have the database instance, and database is something that we never want to be accessed from the internet. It's something that contains sensitive data, because if someone able to log in to our database, it can corrupt our data and hack our services, and we don't want to do it. For that reason, we deploying our database to the private subnet. So no one can connect to our database. It's not possible. The only way to connect it is to connect it through this service in the VPC. And as far as our service 0, that is API, is deployed to the subnet 0, which is public subnet, it receives the public IP address and it accessed from the internet. So whenever someone accesses our API, the traffic comes from the internet through internet gateway, it reaches the subnet 0, and then service 0 can communicate to the database because they are bound all within the same VPC. It can communicate within the database and get all the data. However, direct connection from the internet to subnet 1 is not possible. This is another purpose of subnets, and we usually mark them as the private and public subnets. And literally the difference between public and private subnet is that public subnet maps public IP address to all the services that are deployed to this subnet. That's all, while private does not doing this mapping, so it means that the services are not publicly accessible. And the internet gateway is a function that allows our services to be accessed from the outside world, from the internet. So now let's talk about NAT gateway. And to do it, let's consider another example. Let's say we have service 3. Service 3 is a standalone job. Let's say it's executed on schedule. In doing some data adjustments in our database, so our database is a service 2, let's make connection to it. This service has the TCP server, however, it's only for internal purpose. This service does not have a public TCP server like our API has. That's why we hosting this server in the private subnet, because we don't want it to be accessed from the internet. But our service still requires to access the internet. So let's say we want to go to the external API and fetch some data from there. So our service needs to be able to access the internet, while it should not be able to be accessed from the internet. For that reason, we need something called NAT gateway, NAT gateway. I'll put it over here. This NAT gateway will allow our private subnets to access the internet. So when the service 0 accesses the internet, it uses internet gateway, and the source of the request will always be the IP address of the service 0, right? Because every request has a source IP address and target IP address. Like if you visiting website in your browser, you can just do your IP check. So website can check which IP you visited from, and also you can check what is the IP address of the website. And you can just type in Google my IP address and find out your IP address. Same way happens here. Service as far as it acts as a client, it has the IP address that it visits from. So in case of public subnet, it would be exactly IP address of the service. However, when it comes to the private subnet, this service is just unknown for the internet. It doesn't exist in internet. Only our private network in VPC knows about this service. So NAT gateway helps us to let this service access the internet. Basically, NAT gateway lets private subnets access the internet. So thus our service access the internet through NAT gateway. And when the service acts as a client, so when he reaches some API, the source API from our client would not be the API of the service tree, but actually API of our VPC. So no matter if it will be the service tree, or let's say service 2 also wants to reach out to internet like this, no matter if this or this service will hit the public API, the source IP address will be always the same. It will be the address of the VPC. So that's why we have this network isolation, our private subnet. However, when the service 0 or service 1 reaches out to some public service through the internet gateway, those IP addresses will be different because they are public services that has a dedicated public IP address. Now the question is, what would be the address of the VPC? And to give our VPC IP address, we need to reserve a static IP address, and we're doing it by using the Elastic IP service. So when we just create another resource that's called Elastic IP, it's a static IP address. It will be the IP address of our VPC, and then Net Gateway uses this IP to act as a source IP for access to the public internet resources. Now, there are a few more other important components in AWS VPC infrastructure. They take care about internal networking, and those are route tables. So every subnet within our VPC must have a route table, because route table are something that allow us to resolve internal DNS. And usually there is no requirements how this route table could be created. We can have just one route table for all of the subnets, as well as we have a separate route table for each subnet. But I'm usually prefer to split them by the access. So public subnet have one route table, private subnet has another route tables. The reason behind why we want to have multiple route tables is just redundancy for the reliability. So route tables connected to the particular subnet are located within certain AWS availability zone. For that reason, the more route tables we have, if we have these separate route tables per each subnet, it increases our chances to have the reliable service in case some availability zones have downtime. However, having a lot of route tables create us a bit of a management overhead, because if you want to add some DNS record to our route table, we would need it to add to every table. So I'm usually splitting it by the access, private and public, because it still allows us to have some kind of redundancy. So private route table located in the subnets responsible for the private connections, and public for public. And also usually when we're adding some routes, it is the rare case when we want to add them to the both public and private subnet. So it's a bit of less of overhead. So this is the structure of AWS VPC. And now let's jump to AWS console and create one. So I'm in the AWS console, and now I need to head to the VPC section, then your VPCs. And here we have our default VPC already created. This VPC is created straight away when you create an AWS account. But in this example, I will create one more VPC. So we can click here VPC, and then we can here set up the subnets and route tables and network connection between subnets and route tables. And in this default example, AWS offers us to create two subnets in US East 1A availability zone and US East 1B availability zone. So the respectful route tables. Now I will continue by leaving everything as it is. Now I click create VPC button on the bottom of the page. So it's basically done all of the job we've just discussed. It created all the components, the VPC, the DNS, the subnet, the internet gateway. The only thing it haven't created yet is a net gateway, but let's do it right now. So I just note down my VPC ID. It just ends with CB18. It's called project VPC. And I head over subnets. And here I just want to check which one of the VPCs are private and which public. And let's filter them by the subnets. So now I have filtered them by the subnets, and here I already have the label identifiers identify private and public subnet. And literally what differentiates private and public subnet is just one property. So if we open the private subnet, it has the auto-assign IPv6 address set to null. Let's get back and open the subnet. We should have there the auto assign IPv6 address to yes, but it's set up to no, so we need to edit the subnet settings. And another thing we need to consider in order to make the subnet public is to make sure that it has a respective row tables that connects it to the internet gateway. So here we have the public row tables, we can open it, and here we can see the internet gateway target road that associates internet gateway with public subnet. So that's why we having these subnet public. So each service that will be deployed to this subnet would automatically receive public IP address if we set up it in the settings here. For the private, the services will not receive any kind of public IP address or any kind of public access. They will only be accessible within the VPC. So in this example, we have cost optimized setup. So we have one custom VPC with 2 private and 2 public subnets and internet gateway. So AWS will only charge us for the data traffic that runs through internet gateway. So if we're not running big amount of data, our charges would not be significant. However, in our current setup, our private subnets don't have access to the internet. So if we want our private subnet, the services within our private subnets to reach out to internet, to some external APIs, anything like that, we need to create NAT gateway. So I'm creating the NAT gateway here. Here we need to specify the subnet in which the NAT gateway will exist. So in case we want to have multiple NAT gateways in multiple AWS availability zones, we need to create them separately in each subnet. And in order to create NAT gateway, we need to allocate IP address. So this is something called elastic IP address. We're doing it here. Then click create NAT gateway. So now we have our NAT gateway created, and we also will need to associate it with the private VPC using the row tables the same way as we did for the internet gateway. Right now it's in pending state. The important thing to know about NAT gateway is that NAT gateway has hourly charges on top of the data traffic. So AWS will charge us hourly and also charge for the traffic that we run through the NAT gateway. The AWS promise is to charge us around $35 per month for NAT gateway based on hourly rate. However, from my experience, I found the custom VPC setup cost would be around $100 a month. So now let's head to row tables, and we have the private row table. And now I want to associate it with the NAT gateway like this. Here we're choosing the NAT gateway and click save changes. And we should repeat the same for another private subnet to make sure that NAT gateway is set up. So now our custom VPC is fully set up according to this example. So we have subnets, private, public. We have row tables for private public subnets. We have internet gateway, and we have NAT gateway with elastic IP address. However, in most cases, it's not necessarily for us to create a separate standalone VPC like we just did. We can still use the default VPC, which would work totally fine. By default, the default VPC comes with the subnet per availability zone, and all of the subnets are public here. So if we want to have the private subnets, we would need to create NAT gateway and a few additional private subnets. So let's do it right now. I'll use the default VPC to create a subnet. Then I call it just private, and then I will create it in the first availability zone. AWS already prepared me the CIDR block that matches the VPC CIDR block. I will add another subnet. So I click create subnet. Oops, I need to enter VPC CIDR block. Let's do it like an example. So it's important here to enter the CIDR block that not intersects with the existing subnet CIDR blocks and still within the range of the VPC CIDR block. I just click a random one and try to create one, but the error says it overlaps. So we need to add another one. So here it says that it overlaps with 64/20. So let's do it 128. Yeah, let's do it like this. Well, the easiest way to find the subnet that is not overlaps is just copy all of the CIDR blocks, paste them in the ChatGPT, and ask them to create just new CIDR block that not overlaps but still within the range of the VPC. However, AWS console helped me to find the CIDR block that works well. If you want to learn more about CIDR blocks and how IP addresses are allocated, check out the link in the description below where I'm sharing another video that explains CIDR blocks and IP addresses. So I have created the private subnet. Now I'll go ahead and I have this private subnet, and now I can have services securely running in my default VPC in the private subnet. If I want these services to access the internet, I will just need to create the NAT gateway the same way as we just did. Create a NAT gateway in the VPC, then assigning the row table subnet there. Okay, we have now discussed the default setup of AWS VPC. Let's talk about how we can do it in a cost-effective way. So as I already showed you in the AWS console tutorial, you can either create your custom VPC or you can use a default one. It doesn't really matter. It's just the matter of the clutter that you have. So I'd prefer using the default one when you get. So this is the default setup of AWS default VPC. It consists of just a couple of public subnets that are created for specific availability zone and also the internet gateway. And this might be the best place to get started. So by default, when you will create any kind of service in AWS, you will use this setup. So there is no point to worry about it if you're not concerned about, if you're just prototyping and not concerned about security implications. However, let's say you're preparing really small and simple MVP production application that consists of some API service that is connected to the database. So this kind of setup will appear for you by default. You will put your API service like EC2 instance or ECS task into the default public subnet. The same happens with the database. This approach is flexible because you don't need to worry about VPC configuration at all, and also you can access your database directly from your machine, which is really convenient when it comes to the development and testing environments. However, when it comes to the production environment, and when you're starting getting real user data, and it might be a bit insecure and dangerous to keep the database in the public subnet. Even if you create the security groups that will prevent any traffic to the database except the API, it's still advisable to have this another network level of security. And if you do the completely new AWS VPC setup, it might be cost inefficient for you because, as I mentioned, for me in most cases, the idle state of a new VPC with public private subnets, internal gateway and NAT gateway will cost around $100 a month. It, for most cases, is neglectable when you just running the production environment, but for some MVPs who are not yet funded, it might be the filling cost, right? So in order to extend the AWS default VPC to be secure but yet cost effective, so what we need to do is just to create another private subnet. And as we already discussed, private subnet is just the subnet that is not linked to the internet gateway. So in our row table, we haven't created a record that links the AWS subnet to internet gateway. For that reason, this subnet is inaccessible from the outside world. So we put our database in the private subnet, and that's it. Why it is secure? Because our database is not accessed from the internet. So we can be calm and sleep well during the night, knowing that no one can access the database except our API, which is well implemented following the best security practices. Why it is cost effective? Because creating additional subnet is not a subject for additional cost. So AWS won't charge us for additional subnet. What AWS will charge us for is for NAT gateway. So if we want this database server to access internet, we will need to create NAT gateway, and this is something that might be more expensive and AWS will charge it from us. However, in this simple setup, by adding a simple subnet, and then when you're creating the RDS database instance, you can assign the network configuration to the private subnet you have created. It will help you to achieve a bit of a higher level of security while still being cost efficient. And as I promised at the beginning of this video, here is a special bonus that I have for you. And this is the Terraform code of AWS VPC. So you can basically copy this code, maybe slightly adjust to your specific preferences, and have your VPC set up in just one click. So basically in this code, we have everything that we have just discussed. We have the AWS VPC resource itself. We have the custom CIDR block defined. This data structure is responsible for retrieving the AWS availability zones within the current AWS region. We also have the internet gateway set up, and we have two public subnets set up. You can adjust this number and have more just whenever you prefer. It will automatically pull the separate availability zone from the data resource. Here is also a link to the video that explains how the CIDR blocks are built. All of these numbers mean. This property allows us to apply the public IP address to all the services that are added to this VPC, which is really useful. Also, the AWS private subnet resource will create two subnets. It has everything similar to the public, except that it won't map the public IP address on the launch because services within private subnet are not accessible from the internet. It creates the elastic IP address for the NAT gateway. It creates a NAT gateway. It creates the subnet group for the databases, which might be useful if you want to create RDS database, and it applies the private subnets to this group. So whenever you're choosing the RDS database creation, you're choosing this DB subnet group, and your database will be deployed to the private subnet. It creates a routing table for private subnets and then all the necessary table records. It also has the routing table for the public, and for the public subnet we associate the record, the internet gateway record with a specific subnet, the same for NAT gateway. Here we have the associations between private and public nets and their routing tables and the AWS default security group. And here we have another resource that might be useful when you just want to create the simple extension for your existing default VPC with the private subnet. So this Terraform code basically shows how we're retrieving the information about existing default VPC, its subnets, and how we extend it with the private subnet. So we're using the Terraform data AWS VPC structure here. We're fetching availability zones the same way as we did in the previous example. Now we're getting all of these subnets for this VPC by using this data resource, and we're also extracting the public subnets by just filtering the parameter of map public IP on launch true. Then this code will create two private subnets for us. It also has some smart logic to calculate the CIDR blocks for the new subnets, so they will be within the scope of the default VPC CIDR block and would not intersect with any kind of existing subnets. And you can adjust the number of the private subnets here. So here we have the default row tables, and we would also create the AWS DB subnet group that will let us to basically deploy our database RDS instances to the private subnets only. So we specify only private subnets IDs in that group. And then whenever you're creating the RDS instance, you just specify the subnet group and your database will be deployed to the private subnet. So this is the cost-effective way of how we can extend the full VPC with private subnet versus the complete VPC setup example. So to access these examples, please follow the link in the description to this video, and you can just copy paste this code and adjust to your specific needs. Thank you for watching. If you want to watch more, make sure to click on the corner of this video where my next video will appear. Thank you so much, and if you like this video, please click the like button.